Okay, we are going to be talking about the vertebral column today, which consists of the cervical, thoracic, lumbar, sacral, and coccygeal vertebrae. Here is my real vertebral column, so we'll do a slow pan up there. So we can see all of those sections. So cervical are your first 7, thoracic are the next 12, lumbar are the lower 5, then you have the sacrum, and then the coccyx, which is that tiny little piece there. The last 2 portions of your vertebral column are fused. So they once were individuals, but then fuse. And the sacrum and the coccyx, this portion, also forms the posterior portion of your pelvis. So there are 26 bones as an adult in your vertebra, the 24 vertebrae, and then your fused sacrum and your coccyx. Obviously, your vertebral column serves as protection for your spinal cord. And your spine is not straight, even though we always say sit up straight. Your spine is actually not straight. It's curved, and it has several curves throughout. You'll notice that the cervical and the lumbar curvatures tend to curve inward or anteriorly. And then the thoracic and the sacrum tend to curve posteriorly or outwardly, if you will. And those are the natural curvatures of the spine. And if we have abnormal curvatures, you can see listed there below, that means that we have some alteration to that natural curvature. So the one you might be familiar with is something called scoliosis. And scoliosis would mean that our spine is not in alignment, kind of in the midline of our body. It means that it would be curving in an S or C type shape. So if we were looking at that posterior view of a back, we would see that spine not going straight down, but going like this in that kind of snake or S shape. The second curvature that's listed there is called lordosis. Lordosis is sometimes referred to as sway back. And basically what happens is the lumbar vertebra are going to significantly curve inward. So let's flip back here. So you can see that the lumbar vertebra already curve inward or anteriorly, but in somebody with lordosis, their lumbar vertebra would be coming like all the way here, and that would push their abdomen forward. And again, kind of destabilizing the back region. And lastly, you have kyphosis or hunchback. And kyphosis means that the thoracic curvature significantly curves outward. And so here we see our thoracic vertebra is already doing that. In someone with kyphosis, their thoracic vertebra would curve even further outward. And so we tend to see that in older people, especially as the ligaments and tendons tend to get weaker. And so the ability to hold up that vertebral column starts to decrease. All right, so in terms of our vertebra, in our neck region, we have those cervical vertebra, and there are 7 of them. Our upper back is referred to as our thoracic vertebra, and there are 12. We have 12 because we have 12 pairs of ribs, and every thoracic vertebra is going to articulate with a pair of ribs. And then in our lower back, we have 5 lumbar vertebra. Notice the food times for those to help you remember: 7, 12, and 5, so breakfast, lunch, and dinner. Helping you to remember those numbers for those different vertebrae. In general, we're going to take a quick look at some general characteristics of some vertebra. So I'm just going to grab, this is actually a lumbar vertebra that I'll bring up a little bit later. But in terms of some general characteristics of markings that you need to be aware of. So this portion here that looks kind of like a marshmallow in a lumbar vertebra, but isn't always such, as we can see here in the cervical. It's much tinier, but this is referred to as the body. And the body is where you're going to have an intervertebral disc sit on and above, and that's going to serve basically as kind of a cushion or kind of a bumper in between the vertebra so that they are not rubbing bone against bone. Those intervertebral discs can get irritated and sometimes herniated. And we'll take a look at what that looks like in a little bit. You also have several processes that are going to be located on your vertebra, and you do need to know those. So the one that is posteriorly located is called the spinous process, and that is what you see here. And then you have 2 processes that will be on either side, and since they are on the horizontal plane, we refer to them as transverse process. Okay, so transverse on the sides, spinous on the posterior side of the vertebra. The body will always be on the anterior side of the vertebra. All right, then you have some foramen, and depending on the type of vertebra you're looking at, you may have one set of foramen or you may have two sets. So in a lumbar or thoracic vertebra, which would be these two examples, you will have a vertebral foramen, and that is this opening here. And that is where the spinal cord is going to travel through. In a cervical vertebra, you are going to have two smaller foramen that will be located on either side, and those are called transverse foramen because they are on that horizontal plane. So you have two transverse foramen in a cervical vertebra and a vertebral foramen in a cervical vertebra. In a lumbar or thoracic, you only have the vertebral foramen. And I think those are our only markings that we're going to need to know, with the exception of something in particular for a specific cervical vertebra, which we'll take a look at. You can see also, though, there are other features, various facets and articulating points that are located on the vertebra. There are portions of the bone, the pedicles and the lamina that are connecting body to process to process. Those are good to know, but not going to be assessed on them. So again, your decision to take a look at those or not. Here's what I meant about those intervertebral discs. So in between the vertebra, so we have our connected sort of vertebra here, in between every single one of these would have been an intervertebral disc. And that would be, I'm pointing at it like you can see my hand, that would be this cushion that sits here. And anytime you have an intervertebral disc get damaged or irritated or herniated, it might slip and move into a portion where it might be interfering with the spinal cord. So obviously you can see right here, if this disc were to get herniated or damaged, it might kind of bulge out into this space, and that could potentially put pressure on the spinal cord or on any peripheral nerves, and that might cause some nerve damage or at the very least some significant amount of pain. So sometimes those discs need to be removed or they need to be trimmed down depending on the type of irritation or damage that has occurred. All right, we're going to take a look at each category of the vertebra now and walk our way through. Every single vertebra has a abbreviation, so it will have a letter and it'll have a number so that injuries at various sites can be documented by doctors. So you can see those letters for the abbreviations there. We're going to start with the cervical vertebra. There are 7 cervical vertebra, and 3 of them have unique anatomy and special names. The rest are just numbered. Some of the key features of a cervical vertebra. So this is a typical cervical vertebra. And how do I know that? I know that because its body is small. It has transverse foramen. It has a bifid spinous process. So the spinous process that's located on the posterior side is bifid, kind of like a forked tongue in a snake. And the majority of the cervical vertebra are going to have that bifid appearance. So those 3 characteristics, I would say, are the top 3 identifying a cervical vertebra. So if you just had a table filled with them, you should be able to pick out most of the cervical vertebra based on small body, presence of transverse foramen, and a bifid spinous process. So there is your generic vertebra. And again, looking at the screen and what I'm holding, here is that body. This is my vertebral foramen. All right, it's got a pretty sharp arch there as well. There's that bifid spinous process, my 2 transverse foramen, all right, that are essentially taking up most of the space in what would be my transverse processes, which are here. And then you have some articulating surfaces as well. You have 2 uniquely shaped cervical vertebra that we're concerned with. C7 is the 3rd, which we're not as concerned with, but C1 and C2 we are. C1 is referred to as Atlas. It's referred to as Atlas based on Greek mythology. So Atlas, remember, was holding up the world, and C1 basically holds up our heads. It is the only vertebra that is articulating with the occipital condyles of our skull that we looked at on that occipital bone in our last lecture. And then you have C2, which is the axis. Axis because it's going to allow the head to pivot, and that is C2, and it articulates with C1, providing our head its range of the majority of its range of motion. And C2 has a unique structure that is particular to axis, and that is the dens, otherwise known as the odontoid process. So you can see pictured there, and then I have the two of them in my hands. So you can see that atlas is very uniquely shaped. It doesn't really look like any other vertebra. It does still have the transverse foramen though, so that indicates it as a cervical vertebra. It is a very large foramen, and that is so it can articulate with the axis. All right, so that large foramen allows for the odontoid process, or the dens of the axis, to be able to sit through. So not only do our two facets here articulate with our occipital condyles so that our head can say yes, right? But that dens, all right, that process that is sticking out of C2 allows the head to say no, right? It allows that pivot based on the shape of that process. So both of these, again, have those transverse foramen, those openings on the sides. And you can even see, not so much on C1, but even C2 has that bifid spinous process. All right. The rest of the cervical vertebra, C3 to C6, are going to look like this one until you get to C7. That's called the vertebra prominens. And that is basically kind of a transitional look as we move down from cervical to thoracic. 2, 3, 4, 5, 6, 7. All right. And this is our vertebra prominens, or our C7. So you can see there, compared to C6, it's getting a little bit bigger. Its spinous process is getting a little bit sharper, and its transverse processes are starting to get a little bit longer. So that once we get to T1, our first thoracic vertebra, we are going to start to look a little bit different. Okay. All right. The 12 thoracic vertebrae you have are going to articulate with the 12 pairs of ribs that you have. They have a couple of characteristics that notates them as thoracic. So this is an example of a thoracic vertebra. I would say it's got a much smaller vertebral foramen. Its body, some would say, is a bit heart-shaped, and that's because of this little dip, all right, from that vertebral foramen. It has a very noticeable transverse processes, and along with those noticeable transverse processes, its spinous process is fairly sharp and pointing downward. And if you look at it posteriorly, they tend to look like the shape of a letter T, which is fitting because they are the thoracic vertebra. So those would be our defining characteristics of a thoracic vertebra: a sharp, pointing down spinous process, very pronounced transverse processes, both of those setting up into a shape of a T, very noticeable articulating points for our ribs, small vertebral foramens, and then kind of, if you look hard enough, a heart-shaped body. And there you go in terms of your whole line of T1 to T12. And then that giving you the same view there. That side view, I think, is a little bit better. That sharp spinous process. And again, those are very pronounced transverse processes in that shape of a T. Very noticeable to be able to tell that you are looking at a thoracic vertebra if you were to have them on a table in front of you. Last, in terms of the individual vertebra, are the lumbar, and there are only 5 of these. These are the largest vertebra. They are, they're fairly weight-bearing, right? We've managed to carry our weight all the way down our spine until we reach the lumbar vertebra, and they are definitely noticeably weight-bearing bones. You can see the very large body here that is present. I mean, it looks like a marshmallow to me, or a big giant pillow. So that is very important because, again, weight bearing, all of that weight from your back is being transmitted down into your body of your lumbar vertebra. It has almost a triangle shaped, again, vertebral foramen. So that arch is back. in that vertebral foramen. So that's another identifying characteristic. And then I would say, for me, the last noticeable characteristic of the lumbar vertebra is that its spinous process is kind of blunted. It looks like the shape of an axe, but definitely not as pronounced and sharp as our thoracic, and none of that bifid business that we saw with the cervical vertebra. So looking at your lumbar vertebra, again, a very large body, that triangular shape vertebral foramen, and then that axe shape or kind of blunted spinous process. And again, lots of muscular attachments here at the lumbar vertebra. You can see when all five are put together, they are very thick, significant amount of weight bearing down in that lower portion. And then you can see those same structures I just pointed out and look on your own time in a little bit more detail. Your transverse processes are there. Those are articulating facets are there. Your spinous process, that triangular vertebral foramen, and that very, very large body. All right. This is a good slide to take a peek at, as well as note in your book. It just compares all three next to each other. It's really good to, make a Quizlet with just those three and then kind of pick out those characteristic differences between cervical, thoracic, and lumbar. Lastly, for our axial skeleton, sorry, I'm going to jump until I can get an image for you. So many words. All right, there we go. We're at our sacrum and our coccyx. So the sacrum is actually a fusion of 5 vertebra, and you can see kind of the transverse foramen openings that have occurred there. They're referred to as the sacral foramina when we get down there, but that's what they would be. All of these segments would have been the bodies that have fused together, and obviously large tuberosities and crests that are built out of that fusion. This fusion doesn't usually completely occur until your late 20s. And so that's why, women that have children, especially way younger, all right, so we're going back in time days, medieval time days, women having children at very young ages used to do a lot of damage to their gait, their pelvis, and their ability to walk. And that was because the fusion of the pelvis and the sacrum and the coccyx really hadn't done, as it hadn't completed at that point. And so that could be some damage could have occurred because of that. So not until your late 20s does this completely fuse. Serves as the basis of transmitting that weight from the lumbar vertebra into the posterior portion of the pelvis, transmits that weight to the pelvis, which then transmits it down to the femur, tibia, and then your feet. So those are all very important weight-bearing bones. You don't need to identify any markings on the sacrum, just be able to identify sacrum. And then this little tiny portion at the bottom here, and that is your coccyx or the coccygeal vertebra. These are also fused anywhere from 3 to 5 vertebra that have fused together, very tiny. This is the remnant of what would have been our tail had we still had one, evolutionarily speaking. In obviously animals with tails, they have way more of these vertebra that are not kind of shrunken down and tiny as we have. Anytime you have a spinal fusion, not anytime, a lot of times in spinal fusion surgeries, you are going to see lower back fusions, so L3 to S1 fusions, and that is to essentially alleviate some of that weight-bearing struggles that happen for people who have those types of issues. Again, you can see the curvature of the sacrum and the coccyx, and there'll be differences in those curvatures depending on male or female as the pelvis is formed. Right, and then just another little view there showing the separation between the sacrum and the coccyx, and again identifying that coccyx as being those small fusions of bones.